Hello everyone, welcome to our class on CA Foundation. Guys, we are doing the unit of correlation. In the last class, I have mentioned that correlation is the relationship between two independent variable, and the mathematical term what we use to calculate correlation we use is R of xy. Okay, this R of xy is called correlation coefficient. Okay, we have discussed a method called Carl Pearson coefficient of correlation in the previous class to discuss how we can calculate the correlation coefficient. Now in this class, I will teach you Spearman rank correlation coefficient method. So this is another method, and basically by using this method, we more or less focus on qualitative variables. So when we have qualitative variables and we want to calculate the correlation coefficient, we use Spearman rank correlation method, where the formula of this is R of xy is equal to 1 minus 6 sum of d square by n cube minus n. This is the formula. In some textbooks and all, they'll write the formula as 1 minus 6 sum of d square by n, then n square minus 1. Okay, here the d is basically is called difference in rank. Here d is called difference in rank. Now what is rank? I'll discuss what is rank. First focus on this formula. So the formula of Spearman rank correlation coefficient is 1 minus 6, this is numerical 6, and a sum of d square, then n cube minus n. While in exam, when you are calculating the Spearman rank correlation coefficient, guys, so what you have to do, once you have got the value of sum of d, do the square of sum of d and all. So you'll get the d value, sum of d you'll get, then do the square of d, you will get a d square, do the sum of that, you will get summation of d square. And then first you focus on calculating this value. Once you get this value, then this value what you got, subtract from 1 so that you'll get the R value. So this is another method called Spearman rank correlation coefficient. Let me just discuss theoretical part on this. So here, like you can see, it is studied when no assumption about parameters of population is made. This is Spearman rank correlation, a theoretical definition. This method is based on rank. Okay, so as I mentioned to you that here in this method, we'll calculate the rank. We'll give rank based on the numerical value. Higher value will give higher rank. Lesser value will give lower rank. It is useful to study qualitative measures of attribute. Like I have mentioned before, that this method we generally use to work on qualitative terms. So if when we have qualitative parameters, and for these qualitative parameters we want to find, maybe there are multiple qualitative parameters and we want to find the correlation between them, then this method works better. Like honesty, color, beauty, intelligence, character, morality. Okay, the individual in the group is arranged in order, and they are on obtaining for each individual a number showing his rank in the group. Okay, so this method was developed by Edward Spearman in 1904. Okay, and this is the formula which I told him before only. Okay, so this is the formula to for the Spearman rank correlation. Okay, so if you have not written down this formula, please write down this formula. Some author use the symbol phi for the rank correlation, doesn't matter. Okay, so basically what we do here, what we do here, we'll calculate the R value. Okay, and when there's a tie in rank, what we should supposed to do, that I will tell you. When there's a tie in rank, then this is the formula. Whenever you have tie in the rank, then this is formula. Okay, so whenever there's a tie of rank, imagine two values are same, so you have to give same ranking to them. And whenever you have to give same ranking to them, then you have to work on adjustment factor. Okay, we'll do more numerical so that you'll understand that concept of adjustment factor and all. So like here, suppose first we'll do some simple problem. Here, suppose two data is given, price of tea and price of coffee. And if I ask you, can you calculate the Carl Pearson correlation coefficient, R value, correlation coefficient value, and all, you can easily do, right? You can use the formula R of xy is equal to n summation of xy minus summation of x into summation of y by square root of n summation of x square minus summation of x ka square, then n summation of y square minus summation of y ka square. That formula works whenever we are using Carl Pearson. Here in this class, we are discussing Spearman rank correlation. If you understand the word Spearman rank correlation, the important word what you have to understand here is the word rank. So these values, whatever the price of tea or coffee is given, suppose this is X and suppose this is Y, what we'll do, we'll give them rank. Okay, the rank, the first rank will be given to the value which is highest. So which is the highest? This is rank 1. Okay, 95 is the highest in the call in this row. Price of tea, 95 is the highest. Then this would be second rank. This would be third rank. Simple, right? Then after 88, you have 75, rank 4. Then you have 70, rank 5. Then you have 60, rank 6. Then you have 50, rank 7. Have you understood? Very simple. Similarly, for price of coffee, I'll give this as a rank 1, 140, then 134, rank 2. No, sorry, the highest is 150, not 140. This is rank 1, this is rank 2. After 140, 133, 134, rank 3. Then after 134, you have 120, rank 4. Then you have 115, rank 5. Then you have 110, rank 600, rank 7. Simple. Okay, so like this, we'll have to give the rank and then we have to find the difference. What is the difference of this rank? So 3 minus 4, 1 minus 1, 2 minus 3 minus 1, 1 minus 1, 0. This is 0, this is 0, this is 2, this is 0. And then we have to do the square of the difference. 1 minus 1 ka square 1, minus 1 ka square 1, 0, 0, 0, 2 ka square 4, 0. And then you do the sum. Sum of this would be 6. So this, you'll get the sum of d square. So once you get the sum of d square, for example, is 6, you'll put in this formula 1 minus 6 and the sum of d square is suppose 6. Okay, divide by n. N is the total value. I think there total 7 values are there. So 7 cube minus 7. So if you solve this, you'll get the answer. So 1 minus 36 by 7 cube is 343 minus 7. Okay, so this would be 1 minus 36 by 343 minus 7 would be what? I think that would be 336. Okay, you solve this, this is your answer. Okay, so I hope you have understood. Let me show you. So, so what is given in the book? So this price of tea is given. Now you can see vertical column. Price of tea, I have written vertically. Price of coffee, I have written vertically. Then I've given them rank. Okay, I've given them the rank. You can see the rank. So 95 is the highest value here. So I've given the first rank to this. Then I have 90 is the second highest. I given second rank. I hope you understood how to give rank. So I've given rank to the price of tea. I have given rank to the price of coffee accordingly. Okay, and then I found the difference of the rank. So 3 minus 4 minus 1, that or maybe you do 4 minus 3 1, that you do price of tea minus price of coffee or price of coffee minus price of tea. That doesn't matter. Why? Because ultimately you do the square. When you do the square, everything will become positive. So here 3 minus 2, uh, so here you will give rank. 4 minus 3 is 1, then 3 minus 2 is 1, then 1 minus 1 is 0, 5 minus 5 is 0, 6 minus 6 is 0, 4 minus 2 is 2, 7 minus 7 is 0. Then we do the square of this. Then we'll do the square of this. And so I got the sum of d square, sum of d square. Here I'll get the sum of d square. Here the sum of d square I'm getting as 6. So once I got the 6, I'll solve it. 1 minus 36 by 336 I get, and 36 by 336 is 0.1071. So this is 1 minus 0.1071. So when you'll solve this, you'll get the R value as 0.8929. So this is the R value and a coefficient of correlation value between the two variable. Okay, so the two variables what I considered here is the price of tea and price of coffee. So I hope you understood this. Now going further, there's another, again, in the evolution of the answer script, the following marks are avoided by the examiner. Do you agree with the evolution by two examiners fair? So same student, when two people check the answer sheet, they have given different marks to them. So you just need to compare the marks given by examiner one with the marks given by examiner 2, and you have to understand that that is the marks given by them is fair or not. I mean, there should be a very high correlation between them. If the correlation is low between them, then you can say that you cannot be sure about this fact. So again, this data I given the rank. So these values, whatever these values are there. So we gave rank to these values. Okay. So which is highest? Highest is 95, one rank. This is rank 82, rank 2, then 85, rank 3, then 80, rank 4. Then you have rank 2, then 4. Then after that you have 1, 2, 3, 4. Then you have 60, 60. Then after 80, you have 70, right? So you have 70. 70 should be rank 5. Then you have 60, rank 6. Then you have 50, rank 7. So 1, 2, this should be 5. This should be 5. This should be 6. This should be 7. Okay, so 1, 2, 3, 4, 5, 6, 7. 7 variables are there. Similarly, I've given rank here. 90 is rank 1. Then 88 is rank 2. Then 85 is rank 3. Then after 85, you have 84. 84 is rank 4. 84 is rank 4. Then you have 75. 75 is rank 5. 75 is rank 5. Then you have 55, that is rank 6. 55 is rank 6. And then you have 48, that is rank 7. Okay. So now I'll find the difference. So I'll find the difference. 2 minus 4 minus 2, 1 minus 1 0, 5 minus 2, 5 minus 2 is 3. Okay, 6 minus 6 is 0, 7 minus 7 is 0, 4 minus 3 is 1, and then 3 minus 5 is minus 2. Okay, then I'll do the square. Minus 2 का square, minus 2 का square is 4, 0 का square is 0, 3 का square is 9, 0 का square is 0, 0 का square is 0, 1 का square is 1, minus 2 का square is 4. And then I'll do the sum. So sum of d square I'll get is 4, 4, 4 plus 9, 13, 13 plus 1, 14, 14 plus 4 is 18. 14 plus 4 is 18. So I can, let me check again. 4, 5, 5 plus 4 is 9, 9 plus 9 is 18. So I got sum of d square is 18. So I'll apply the formula. So I'll apply the formula 1 minus, I'll apply the formula. When we'll apply the formula, it is 1, R value is 1. Sum of d square you got is 18. Okay, sum of d square you got is 18. So R of here, if I want to find R of xy, 1 minute, there's a problem with the pen. So if I want to find R of xy, so what I will do, okay, let me open Excel. So one sum of d square you got is 18, right? So the d square sum is 18. Okay, d square sum is 18. So what you need, 6 into sum of d square. So 18 into 6, 18 into 6 if you do, 18 into 6 if you do, you get 108. So 108 you got. Then n is 7 if I'm not wrong. 1, 2, 3, 4, 5, 6, 7. Total 7 values are there. So what is 7 cube minus 7? 7 cube minus 7. 7 cube minus 7 is 336. So you will get the answer as 1 minus sum of d square into 6. That is 108 divided by 336. Means n cube minus n. If you do this, you will get the r value as 0.678. This is your R value. Okay, everyone. Let me try. Yeah, pen is working now. So you got the sum of D square as 18 and the formula of R is 1 minus 6, 1 minus 6, 1 minus 6 into sum of D square by n cube minus n. So if you use this formula, you will get 1 minus 108 by 336. So if you solve this, you'll get the value as 0.678. 0.678. This is your R value. Clear, everyone? Anyone have any doubt? You can use comment option for asking any doubt if you have. So like this, we can find the R value. Okay, again, like this test score is given for the two students and all. Okay, and then you have to find the R value. Again, apply the same logic. These test scores are given. Just write down the data vertically and give them rank. Then find the difference of the rank. Then do the square of the difference. Okay, so here repetition is there. Okay, let me do this question where there's a repetition. So how will you do when there's a repetition in the problem? Okay, let me take the screenshot. Yeah. So imagine this is the value given to you. Okay. So test one. So these values are given to you. And let me put in Excel only. Test one, then test two. Test one is 70, 68, 70, 68, 67, 55, 60, 60, 75, 63, 60, 72, 60, 72. How many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 values should be there. Here, total how many values are there? Count 10 values are there. Now test code to 65, then 65, then 80, then 60, then 68, then 58, then 75, then 63, 55, then 63, 60, 70, 60, and then 70. Okay. So now what we'll do, we'll give them rank. Okay, we'll give them a rank of 1 and a rank of 2. Okay, so we'll give them rank. Now, while giving the rank and all, what you can do when you are giving them rank, what you can do. Okay, so what I'll do, I'll see the value which is highest. I'll see the value which is highest. The highest value here is 75. No, so the value which is highest is 75. So I'll give rank 75 as rank 1. Okay, the value which is highest is 75. So 75 I have given as rank 1. 75 I have given as rank 1. Then I have 72. Then after 75 I have 72. So 72 I'll give, this is rank 1, this is rank 2. Okay, then I have 70. This would be rank 3. This would be rank 3. Okay, then I have 68. This would be rank 4. Then 67, rank 5. Then I have 63. 63, it would be rank 6. Okay, 63, it would be rank 6. Then I have 60. 60 means there's a tie of rank 7, then rank 8, and then there's a rank 9. 60, 60, 60. So there's a tie between 60 is appeared 3 times, 60 is appeared 3 times, and there's a tie between rank 7, rank 8, and rank 9. So in this kind of cases, what we'll do, we'll find the average of these three ranks. So 7 plus 8 plus 9 divide by 3. So 7 plus 8 is 15, 15 plus 9 is 24, 24 by 3 is 8. So we'll find the average of this, and that average will give to all the three rank. So 8, 8, and then 8. So total we have given rank to 9 variable, and now the 10th one is 60, which would be the rank 10. I hope everyone understood this. Similarly, we'll go with the test score 2. And in test code 2, what we'll do, the highest one is 80. I can see 80. 80 would be rank 1. 80 would be rank 1. Then after 80, you have 75. 75, it would be rank 2. Then you have 70. 70 would be rank 3. 70 would be rank 3. 70 rank 3. Then after 70, I can see 68. 68. 68, it would be rank 4. 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 Then there's a tie between rank 5 and rank 6. You can see there's a tie between rank 5 and rank 6. So 65 has appeared 2 times, and there's a tie between rank 5 and rank 6. So what I'll do, I'll take the average of this. So average of this will be 5.5 and 5.5. So total 6 ranks are done. Okay, then you have 63. 63 will be rank 7. 63 will be rank 7. 63 will be rank 7. And then I can see a tie between rank 8 and rank 9. So average of 8 and 9 would be 8.5. So 8.5 and 8.5, and then 58 would be rank 10. Okay, so like this, we gave the rank. So when we gave the rank, what we realized here that we have in test 1, we have this value called 60. We have this value called 60 in rank. In test 1, we had this value called 60. We had this value called 60. 60 has appeared 3 times. 60 has appeared 3 times. So we had this value called 60, and 60 has appeared 3 times. M represent the number of times the value has appeared. Then in test 2, you had 65, which has appeared 3 times, sorry, 2 times. Then you had this value called 60. Then you had this value called what value? 60 again in test 2. This is in test 1. This is in test 2. This is in test 2. You had this value called 60, which appeared 2 times. Okay. Which has appeared 2 times. So what you have to do? You have to find the adjustment factor. You have to find the adjustment factor. Okay. That adjustment factor formula is summation of m cube minus m by 12. Okay, m is basically the number of times the value is repeated. So here if m is 3, if m is 3, then your adjustment factor would be 3 cube minus 3 by 12. 3 cube is 27, 27 minus 3 is 24 by 12. You will get the value called 2. While if your m is 2, your adjustment factor would be 2 cube minus 2 by 12. 2 cube is 8, 8 minus 2 is 6 by 12. If you do, you will get zero point 0.5. So you can by heart this value also. If the value is point, if the repetition is 2, then your adjustment factor would be zero point 0.5. If your repetition is 3, your adjustment factor would be 2. And then what you can do the sum of this m cube minus m by 12, and this if you do, you will get the adjustment factor is 3 here. Clear everyone? So here you got the adjustment factor whenever there's a repetition of rank and all. So then whenever there's a repetition of rank, whenever there is a repetition of rank, whenever there's a repetition of rank in the calculation in the formula, then your R formula will become 1 minus 6. Okay, sum of d square plus adjustment factor divide by n cube minus n. Whenever there's a repetition of rank. When there's no repetition of rank, then you don't have to use any adjustment factor. So whenever there's a repetition of rank, then you use this adjustment factor calculation. Okay, in this textbook, it is given direct. Okay, in the textbook this is given directly within the formula. So but this looks very complicated and all. That's why what I do normally, I do it separately. This adjustment factor calculation and all, I do it separately, and then whatever the value I get, that value I add with the sum of d square. I hope you're getting it. So here now what I will do, I'll find the difference of rank. Here what I'll do, I'll find the, okay, I'll do find the difference of rank. I'll find the D. D is nothing but difference in rank. Okay, I'll do the square of this difference. I'll do the square of this difference, and then I did the sum. I'll do the sum. Sum of D square I'm getting as 50. Okay, so the sum of D square here I'm getting as 50. So the sum of D square is my 50. Okay, and what is my adjustment factor? My adjustment factor here I got is 3. If I'm not wrong, I got my adjustment factor as 3. So my adjustment factor is 3. This is my 3. And sum of D square I got as 50. So I'll apply the formula. So the R value is 1 minus 6. Sum of D square is 50 plus 3, which is the adjustment factor divided by N. N, if I'm not wrong, is 10. So 10 cube minus 10. This is your calculation. Okay, so if you do this, you'll get 1 minus 6 into 53 by 1000 minus 10. So here, what is 53 into 6? What is 53 into 6 is 318. 318, then it is 1000 minus 10. N cube minus n is 990. So 318 divided by 990 is 0.321, and 1 minus this value is 0.678. So if you calculate this, so the R of xy you'll get is 1 minus 318 by 990. If you calculate the R value, you'll get is 0.678. This is your R value. Okay, everyone. So this mechanism we use whenever there's a repetition of rank. When you're calculating and when there's a repetition of rank, you'll do the calculation like this way. Okay, you can see this. So you can, so either you can do like this complicated way like this. You can pause this video and you can just go through this, what I have done. You can go through this. uh, So what, instead of doing in complicated way, what I did, I'll find the sum of d square, and then separately I'll do the adjustment factor calculation. Otherwise, keep in mind that if any value is repeated two times, then the adjustment factor will be zero point 0.5, while if the value is repeated three times, then your adjustment factor will be 2. So remember this, you don't have to calculate exam and all. When it is objective type exam, where nobody's gonna see your steps and all, you keep this in your mind. When people are there to see your steps and all, that time what you do, just show this. Imagine in your BCom and all when you are doing, then show your steps and all. But here you can ignore it. So I hope you have understood this concept. So this is about Spearman rank correlation method. Okay, how to do the numericals based on Spearman rank correlation method that I have discussed in this class. Thank you everyone. Bye.